Okay, so we're gonna talk about vectors and scalars. This is PDP lesson 3, I guess. So who can tell me what we just talked about? What did we say? Actually, you can all do it. Say to the person beside you what I just said. Chloe, you tell me. So there's 2 answers, right? Sorry for you if you're watching the video. So here's my summary. I got Lola up here and we took a measuring tape and she took the end and she walked 6 meters north. And then she went around Danielle and she came back 4 meters south. So this is how you would draw this, right? 6 meters to the north and 4 meters to the south. And then we asked, how far has she gone? So the answer that pops into your head is 10, because she walked a total of 10 meters. But then we asked, if you were asking somebody if she was lost in the woods and you knew she'd gone 6 meters north but then 4 meters south, the answer to where she is, her position, is 2 meters north, right? This is what we call the resultant vector, VR. It's like the answer, okay? Resultant vector. So you're probably getting the picture of this already. There's vectors. There are vectors. There's also vectors, and there are scalars. So you can answer this question of how far Lola went. You can say distance. And the distance is just 10 meters. The displacement, however, is 2 meters. But is that correct? Are these correct? Kind of. There's something missing though. Good. Aria's on it for vectors. We just put them in square brackets, just a convention. But the vector has to have direction. So this, the distance, is a scalar. The displacement is a vector, and it has direction. So if you're adding vectors, this is the way you do it. You draw an arrow, and then you draw the next vector, and we say we draw it tip to tail. Draw vectors. When you're adding them together, you draw them tip to tail. Can you read that? You guys see that? It's a little messy, sorry. When you look up here at these relationships and formulas on the wall, if you take physics, you're going to use lots of these. And there's lots of D's and B's and A's and T's, and these are all vectors. So displacement is a vector, velocity is also a vector, acceleration is a vector, force is a vector. Tell me something that you think is a scalar. Anisha? You said it.
Distance?
Yeah, that's good. Distance is a scalar. What makes this a scalar as opposed to displacement?
Direction.
Yeah, this has a direction, distance does not. So distance doesn't care about the direction. Doesn't care that you went north and then south. It's just add everything up. It's only the magnitude. It's only the quantity of what you did. Doesn't care about direction. The easier way to add this up is to say, well, why don't we say that north is positive and south is negative? Yeah, sorry to the Australians, but north is positive, south is negative. If we did that, we would say, okay, well, if this is positive, this is plus 6, and then we're adding what to it?
Minus 4.
Good. Negative 4. And that equals what? Plus 2, right? Which is 2 meters north. Right? This is a really simple example, but this is how we add vectors, and there will be really complicated examples. But the concept is the same. When you take into account the direction, if you're doing distance, it's just 6 plus 4. We don't care about the direction. There's no negative. But if we're adding vectors, this negative becomes a direction. Now, I just decided that north was positive and south was negative. So that's obviously true. But who decides which way is positive and which way is negative? Physics does? Maybe, yeah, that's a good guess. Hold your finger in the air. Put your finger up like this, and then turn it like this. That's who decides whether it's positive or negative. You do. You can decide. And if you made this negative, if north was negative and south was positive, what would the answer be then? It would be negative 2, which would be fine, right? Because negative would be north. It's still 2 meters north. So you can decide what's positive and negative. You just have to keep it the same throughout your problem. Okay, that was an introduction to vectors. I'm gonna leave it there for now.